Hi people, welcome to I think this will be the last lesson in this section here. I think I'm looking at exercises 2 on Blackboard, the exercises 2. I'm going there, exercises 2. Hopefully it's that one. No, it's exercises, I think it's exercises 3. Exercises 3, vectors and resultants. Yes, there we go. Then if you are aware, you can rotate this, okay? You can rotate this by that button over there. Okay, but it then rotates every page in the document. I'm looking at number 5, okay? Right, there's number 5. 3 forces in equilibrium are represented by the diagram. Calculate the magnitude and direction of F and R. Okay, right. Now, when you get a problem like this, people, notice they only give you the lines of action of the force and the directions they're acting at. You don't know whether it's pushing toward the joint or pulling away from the joint. Okay, so what I'm going to do, I'm going to assume that both are pulling away from the joint. Alright, so let's see. So I'm going to assume that F is doing this and R is doing that. Okay, so they're both pulling away from the joint there. Notice the word assume. I'm assuming that. And of course, all forces not acting vertical or horizontal must be resolved into components. That means I must resolve the 800 Newton force and force F into its components, but not that one. Right, I'm going to draw the north-south lines about that point like so. And of course, this one is just going to be an extension of force R there. Okay, right, let me write in. So that's 45 degrees. This is 45 degrees here. Remember I said the last time, this angle here is 75 degrees. You never use an angle between forces. Never. It's going to be wrong. Okay. So that's 45 degrees. And that's going to be 30 degrees. There we go. It's going to be 30 degrees. So that's 30 degrees. So 800 Newton is 30 degrees to the horizontal. And F is 45 degrees to the vertical or the horizontal. It doesn't matter. Right. I'm going to resolve these forces. Right, let me do this one like so. And this is going to be F cos 45, F cos 40. It doesn't matter. I'm going to keeping with for the practice. F cos 45, F sin 45. And I'm going to do that one. Let's say in that color there. Right, so that's going to be horizontal, and that's going to be the vertical one. Right, so if that's 30 there, that's 30 over there. So that's going to be 800 cos 30, 800 cos 30. And by the way, that's actually a value we can write in, isn't it? So I'm going to do that now. That's a value we can actually write in, 800 cos 30. 800 cos 30 is equal to 692.82. So that's 692.82 newtons. And that there will be 800 sin 30. Sin 30 is half. So what's half of 800? So it's actually 400 Newton exactly. Right. What's the next step? Some verticals, some horizontals, and equate them equal to 0, because why? This point here about which the force of acting is equal to 0. Right. So I'm going to say the sum of the forces vertical is equal to 0. So I've got minus F cos 45 minus F cos 45 degrees minus R minus that minus 400. So equal to 0. So I've got 1, 2, 3. It doesn't matter the order. Just take them all. Okay. Minus, minus, minus. Right. Can I solve it? No, because I've got two unknowns there. Right. Sum of verticals. Sorry. Yes, sum of verticals is that? Sum of horizontals equal to 0. Sorry. There we go. Sum of vertical, sum of horizontal. So I've got 800. So that is plus 692.82. It's plus because it's going horizontally to the right. So it's plus this one minus f sine 45. Equal to 0. There's only that one, there's only that one. Right. Do I need to solve simultaneously? Not exactly. I got one equation with one answer, therefore I can solve f. So from there, f is equal to, do the calculation and see what you get. I get f as 979.80 Newton. Okay, so f is set over there. And right, so that's not. So if I'm checking my answer, yippee. And notice there, they call that a tensile force. I can't agree with that completely. But what they mean, well, the author actually means tensile force, means the force is pulling away from the point. Remember I spoke about thrust and ties? The author says that this is a tensile force. Okay? It's not a member, but because it's pulling away from the joint, he calls it a tensile force, or she. So that one's okay. So that one's correct. Right. So what I'm going to do, I'm going to take this now and I'm going to put it in there. And I can solve for R. Okay. So therefore R is equal to, if I move R over, R is equal to minus F cos 45 minus 400. And I find, right, you need to check me, I find R is equal to, let me write that fully, R is equal to minus F cos 45 minus 400. Okay. So it'll give me an answer of, yes, a big negative number, N0.82 newtons. Okay. Minus 1092.82 newtons. Right. Something new. What does the minus sign mean? The minus, now remember, F and R, we didn't know the directions. Okay. And because I got a positive answer for F, my assumption that F is pulling away from the joint is in fact correct. Okay? The minus sign here for R means that my assumption that R is pulling away from the joint is in fact not correct. So it's actually pushing toward the joint. Okay? That's what the minus sign means. It means that my assumption of direction is incorrect. Okay, so let's go to the answer. It says, notice there is 1.093. If I convert that to kilonewtons, that will give me 1.09, and there's an 8 there. So there we go. So it's perfect. Okay, and it calls it compressive. What does it mean? It means pushing toward the joint. Okay, so there we go. So that is how you solve that. So if you are given forces to solve and you've got no directions, you must assume a direction. You resolve into components, use some vertical and some horizontal forces, and then from there you'll see that if you get a positive answer, your assumption for the direction is correct. If you get a negative answer, that means your assumption for the direction is incorrect. You need to switch it around. Okay, so F is equal to this and it's pulling away from the joint. R is equal to that. If you left it as 1/92.82, I would have left it like it. I wouldn't have done this, but it's not wrong. Okay, I would left them all in newtons. Okay, so, and because it's negative, it means that the force is not pulling away, but actually pushing toward the joint over here. And the author says compression, because if something is in compression, it looks like this. And if a member is in tension, it looks like that, as I said in the previous lesson. Okay, so that is how you do number 5. Okay, I might do one more in that exercise. I'll clean the board and then we can have a look at it. Alright, people, in the same exercise there, number 10. Number 10 looks like such. Okay, that's it's in the same document. There, I just did that one, number 10. Okay, I just dropped it into your page there, onto the board there. Right, just sorry, but I couldn't get this bit away. Just ignore this, okay? Sorry, man. I just couldn't get this thing want to come along. We don't want that. Right. The ends of a light rope, ABCD, are connected to the same horizontal beam over there at A and D. Masses of M kilogram and 1 kilogram are suspended at B and C so that the rope forms angles as shown in the diagram. Calculate the magnitude of the mass M at B. That should be a B there, okay? Right, people, the first thing you do is before you make a mistake, before you lose sight of it, convert that to newtons. How do we convert it to newtons? Convert it to a force, okay? It's 1 times. In this course, G is 9.81. It's not 10. It's not 9.8. It's 9.81, okay? So 1 times 9.81 is 9.81 Newton, okay? G is not 10. G is not 9.8, it's 9.81. Okay, we assume it to be for this course. Right. Now, people, what you do is there's a joint and there's a joint. So what you're going to do, you're going to consider forces around this joint here, and then proceed to the calculations here, find things out, you determine tensions here, and move along there. And by the time you get here, you should be able to find M over there. Okay. So I'm going to look at I try to make it as big as possible. So I'm going to, right, let me first draw in my north-south lines there. Right, there's my north-south line there, and there's my, okay. Now remember, tensions, as I said previously, are all pulling away from the joint there. So I'm not concerned with that end of this rope. For the moment, I'm not concerned with this end of rope CB, and I'm not concerned with rope BA at all at this point. Okay, so tension there, and tension over, tension over there, like so. Okay, so I'm concerned with the lower end of CD and the left hand end of CB. And of course, because they're both at an angle, I need to resolve both of them into either components. So that's just going to be like so, and that's going to be like so. Right, and I must name them. Right, that's 120. Okay, so that's going to be 60. So that angle is going to be 60. Never use an angle bigger than 90. Use a small angle. So that's going to be, and let's call it a CD or DC. So this is going to be CD cos 60. CD cos 60. I'm not going to do the whole one. I'm just going to start you off. And this is going to be CD sin 60. CD sin 60. Okay. Alright, I'm going to resolve that one there. I'm going to choose another color. We choose this magenta color here. Okay. And I'm going to resolve it into its components. It's going to look like so, and it's going to look like that over there. Okay, right, that angle is 75, so that angle there is 75, so that means that angle is 75. Get it right. Okay, so that's going to be CB cos 75, CB cos 75, and that's going to be CB sin 75, CB sin 75 degrees. Okay, run. Now the next thing I do, I sum verticals, I sum horizontals like I did normally. Okay, let me make it blue. So I'm going to say, let me just, the sum of the verticals is equal to 0. Why is it 0? Because the whole thing is in equilibrium. Run. Vertical forces, I've got this one, I've got this one, and I've got that one over there, acting vertically down. So CD sin 60, and it's plus because it's going upwards, plus CB cos 75, plus CB cos 75, minus 9.81. Now, if you didn't do that there, and you put a minus 1 for the killer, it's wrong. Because that's forces, and that will be a mess. It'll be completely wrong, and everything will be wrong from that point onwards. So that's why I say do that first. Minus 9.81 is equal to 0, because there's no more vertical forces. So plus, plus, minus. Right, can we solve it? No, we've got two unknowns. Right, let's sum horizontals. How many horizontal do we have? We've got 2. Minus plus. So it's minus CD cos 60. CD cos 60. Plus CB sin 75. CB sin 75 is equal to 0. Right. And of course, now you need to solve simultaneously. So you find CD and you find whatever way you do it correctly. Okay. And from there, I found, what did I find? I did a calculation ahead of time. I found CB to be equal to 5.664. Hang on, let me just get it correct before I make a mistake. Yeah, I found CB to be 5.075 newtons. Okay, right. Now remember, we're not concerned with the tension in CD. You can determine it, but it's not needed. Okay, we want to get to M here. Right. So the tension in CB is 5.075 newtons. Now remember, we're now going to go to the next joint. Right. So let me draw the next joint out there. Looks like this. There's my north-south line, and there's my east-west line about there. Okay. Let's see if I can make it bigger. Here we go. Make it bigger. Okay. Right. Now, I'm going to have to resolve. Now, remember tension sitting over here. Tension in CB is sitting like this, and there's tension in that rope over there as well. Okay. So, before I can solve here, I will need to resolve that force into its components as well. So, this is going to be looking like that. I'm just going to squeeze it in here, and that's going to be looking like that over there. Okay, so this known force, now remember, this is the tension in rope CB. Okay, so the tension here in the rope from C to B is the same throughout. Okay, so let's see that angle inside here. Maybe I should change the color. That angle inside there is 75 degrees. So this vertical component here is going to be equal to CB cos 75. But we know what CB is. CB is 5.075. So if I take 5.075 times cos 75, I get 1.31 newtons. So that's going to be 1.31 newtons. And that component there is going to be CB sin 75. So it's going to be 5.075 times sin 75. So it's going to be 5.075 times sin 75, and that's equal to 4.90. So that's going to be 4.90 newtons. Okay, and of course you need to resolve there as well. Okay, so if I just do that there, that angle inside there, how much is that angle? That angle is how much? That angle is 30 degrees. So that there is going to be 30. So this component here is going to be AB cos 30. And that's going to be AB sin 30. And now I'm going to solve vertically and solve horizontally. So when I sum vertically, I got AB sin 30 minus 1.31 minus, now remember, M is a mass. Okay, but remember, before you do that, consider in this case, remember I always said start with the verticals. The reason why I say that, because when we start with the verticals, almost every time you are able to determine something first on the verticals and then the horizontals. Okay, that's from experience. Right, now if we solve horizontals here, I've got minus 4.90 plus AB cos 30 is equal to 0. If I solve horizontals, I've got minus 4.90 plus that equal to 0. And from there, I'll be able to determine AB. And from AB, I find AB equal to 5.660 newtons. And of course, once I got that, and I sum verticals, I can now I know everything else, I can now determine M. But remember, when I find the value for M, I'm first going to get the weight of M. But we want the mass. So once I found the weight there, I must divide it by 9.81, and that will give me the mass of mass M, the mass of mass M. And the answer that they give there, the answer that they give there is nogal perfectly correct. Okay, so what I'm saying is, so once you found the answer here, okay, once you found, you're going to find the weight for M, okay, and of course then you divide it by 9, or divided by G, and that will give you the mass that you can hang there, and the answer you get is 0.1547 kilogram. So people, that is how you take that one there. So very briefly, what you do is, you first work around this joint, find CB, go to the next joint, okay, and once you get here, you need to solve tension in CB from that end, like with that horizontal and vertical there, and then you sum forces horizontal, vertical, find AB, and then you find the weight of M divided by 9.81, and you find the M, the mass you can hang there, which will be that answer over there. Okay, people, so that is how you do that. And I think this is going to be the last video for forces, resultants, vectors, etc. Now you should be able to do all of them. There's another fishboard exercise very similar. There's another one, by the way. That should be, that there should be 3 times root 3. Okay? Not cube root 3. That's correct. That's wrong. That should be 3 times root 3 kilograms. You got more of that. There you've got some more examples. We have to assume directions for R and F, and if you get a negative answer, your direction is wrong. You need to turn it around. Same there, and do now. And if you want to, you can have a go with those two if you want to. If you don't, that's okay, because that's going to be the next big lesson. All of this, all forces here, is leading up to solving forces in frames and determining the size of the forces and whether the forces are in tension or compression. Okay, so once you get here and you finish off, that's okay. If you want to have a go, you can do so if you want to, but if you do all of this here, then you're doing well. Okay, the answers are there. Work toward the answers. If you have a question, send me an email. Don't wait until tomorrow or the next day or the next year. I might not be around, or I might be teaching somewhere else. Ask me as soon as you can by an email. Okay, people, all the best, and I think that's the last lesson for forces, vectors, resultants, etc. And the next big topic is going to be forces in frameworks. We're going to look at this. Okay, right, I'll see you in the next video.